Project code ITPW37. Project title 3-phase to single phase multi-resonant direct AC to AC converter for metal hardening high frequency induction heating application. Abstract. Before going to the abstract, first we see about voltage source inverter. Actually, conventional for this proposed system is voltage source inverter. In voltage source inverter, convert 3-phase AC into 3-phase DC into AC. But in a proposed, but this AC is not suitable for induction heating application. But in this concept, the main focus for the induction heating is to get a high frequency. In general, the utility grid frequency is 50 Hz. The greater than 50 Hz in terms of kilohertz is named as a high frequency. In existing concept, the voltage source inverter, the output of the inverter is like a only 50 Hz output we get for the DC to AC operation. And the existing have the drawback of the conducting current is low because there is no bidirectional switches. If you use the bidirectional switches instead of the leg, like two switches, we have to use the bidirectional switches. It have the capable of bidirectional switch, capable of reducing the conducting current. It is a main drawback of the existing concept, and it has a very low frequency, actually the utility grid frequency. So in case the frequency increases, the system size decrease. So the existing concept it's not compact and the more switches are required. In case in existing voltage source inverter DC to AC concept, we need 6 switches with the 6 pulses. 6 switches with the 6 pulses. But here we need 6 bidirectional switches with the 3 pulses. In a proposed concept, input is AC. In existing DC to AC converter, it is not suitable for the AC input application. But here we introduced the AC to AC, but the 3-phase AC to single phase AC. Because the induction heating equipment is always single phase. But in case any induction heating equipment is having the high current rating, so the 3-phase input is needed for the induction heating application, but it is work in a single phase. In this system, here we use the bidirectional converter, bidirectional switches, 3 bidirectional switches connected parallelly, each having 2 switches. And using the pulse width modulation technique, we have to generate the pulse and given to the bidirectional switches in our proposed resonant converter. And the output of the single phase, after using the induction heating machine, the power factor we have to maintain unity. It is very important for that. When using the induction heating machine, it have the inductor and it lack the power factor. But in a proposed concept, the power factor is maintain unity and the total hardware distortion is also low. And the system is compact because using the bidirectional switches with high frequency and the cost effectiveness and the high efficiency. This is a black diagram. Again, I said 3-phase to single phase conversion. And because the induction heating equipment all are single phase, in between we uses the bidirectional switches with some capacitor, like switched capacitor, combined to form our proposed converter. And the PWM pulse width modulation technique used to generate the pulse and given to the bidirectional switches. And it is mainly used for induction heating application and also for the motor drive application also. In VFD drive, conventionally used voltage source inverter, but in this system in the AC to three-phase AC to single-phase AC system is used for the VFD drive. It is economical and the cost-effective. The system is implemented using the simulating tool MATLAB 2015B, and in hardware prototype, the PIC microcontroller is used. In this PIC microcontrollers, we have to fed the program by using the MP lab, microprocessor lab. This PIC microcontroller generated the pulses and given to our proposed converter switches. Hardware requirement, minimum hardware requirement is MOSFET and a transformer. The transformer is used to give the excite the PIC microcontroller, because PIC microcontroller have the voltage of 5 volt DC, but the transformer produces a 12 volt AC and regulated and converted into DC and given to the 5 volt to the PIC microcontroller. And other passive devices, diode, IC and the inductor capacitor resistor are also used for our proposed converter. Thank you.